Namaste. In this video, we will be going over right angles. So what is a right angle? These are any angles that measure exactly 90 degrees. So how would this look like if I were to construct one? Well, let's see. So using my ruler, I can construct a right angle by drawing two lines that intersect at a common point. These two lines must form a 90-degree angle, like this. So that is a right angle. Now let's define complementary angles. These are any two angles that add up to 90 degrees. Let's look at an example. So first I'm going to construct a right angle that intersects at a common point. And I'm going to split this right angle into two separate angles. One of these angles can be called x. And since we know that this forms a right angle, this angle can be called 90 minus x. And the reason why is because if we added x and 90 minus x, we would then get 90 because these two x's cancel out. So for angles to be complementary, they must add to 90. Let's now define perpendicularity. What it means for two lines to be perpendicular are that they intersect at right angles. Let's construct an example. So if I had one line and I called this line A, and I had another line and called this line B, and these lines intersected at right angles, they would be called perpendicular. And the way to denote this is by saying A is perpendicular to B. This symbol right over here denotes perpendicularity. Now let's define what it means for two lines to be parallel. These never intersect and always maintain the same distance. Let's look at an example. So if I constructed line A and I wanted to construct another line that's parallel to line A, what do you think that would look like? Well, this is no different than just making a copy of line A. And I could do that 20 meters above, 2 meters below. It doesn't really matter as long as they are the same distance away. And the way we denote that two lines are parallel are using these small arrows. It's really important that you write these on your diagram so that the viewer knows that these lines are parallel. And unlike perpendicular lines, these lines always stay away from each other. In other words, they are equidistant. Okay, now let's try out some practice problems. I hope all of you guys can pause the video and give them a shot. So let's get started. For the first problem, we're given a diagram with a right angle and a missing angle measure x. The way I know this is right is because of this symbol right over here. So how can we solve for x? Well, remember that x must be complementary to 57. Remember, for complementary angles, they both add up to 90. And since this is a right angle, I can set up an equation. X plus 57 equals 90. And now, to solve for x, I simply subtract both sides by 57 and get that x equals 33 degrees. Now for question 2, I'm not given a diagram. Instead, it's given that angle A and B are complementary. They add up to 90 degrees. We know that A measures 78 degrees, and we're trying to solve for the measure of angle B. So, like question 1, we can set up an equation. If I know that A is 78, and I'm trying to solve for B, I can say that 78 plus B equals 90. And then to solve for b, I'd simply subtract both sides by 78. And I get that b is equal to 12 degrees. For our third and final problem, we're going to do it the same way, except we have different numbers. So I'm once again given a diagram with a right angle, and I'm trying to solve for x. Like we did for the first problem, we can set up an equation. We know that x plus 41 must be equal to 90. And by subtracting both sides by 41, we get that x is equal to 49 degrees. We're now asked to select all of the right angles. So I highly encourage you guys to once again pause your videos and give the problem a shot. So assuming you've done so, let's see if we can identify the right angles. Remember that in order for an angle to be right, they must be represented by a squarish looking symbol like that. If they're not, we can't assume they're right. So let's see which diagrams have that. The first one, I do see a square, and therefore I can assume it's a right angle. The second one, well, no, 137 degrees is greater than 90. In the third diagram, I do see a square, and I also see that it's labeled with a 90. So therefore, it has to be right. For our next diagram, we do not see the square, and therefore, it is not 90 degrees. For our next one, we don't see any labeling, so we cannot assume that it's a 90 degree angle. So that is not a right angle either. And finally, for our last diagram, 305 degrees is too large to be a right angle, so that does not satisfy our conditions. For our last practice problem, we're asked to draw a shape with parallel sides. Remember that parallel sides never intersect and are always the same distance from one another. So there are several possible shapes that I can draw. I can draw a square, a rectangle, a parallelogram, a rhombus, a trapezoid, and maybe even a hexagon. But what I want to essentially do is mark my shape with the correct symbols. That's very important. So let's see how I can do that. For this practice problem, I'm going to construct a square. So remember, a square has 4 right angles and 4 congruent sides. And all these sides intersect at 90 degree angles. So how can I denote that each of these sides are parallel? Remember that in order to do so, we use these symbols. So this side that I just drew is parallel to this side. Now, if I wanted to denote that this side is parallel to this side, I would also use the same arrows, except now I use 2 of them. So, therefore, a square is a shape with 2 sets of parallel sides. If I wanted to construct a rectangle, the process would be the same. What about a trapezoid? Well, let's see. A possible construction for a trapezoid would look like this. And notice how it only has one set of parallel sides. Only this side is parallel to this side.